Okay, this is the Chapter 11 review. Chapter 11 started on page 710, and the first two things that we started looking for in sections 1 and 2 were circumference and arc length, and then area and sector area. So we have two formulas. First, the circumference of any circle is 2 pi r, or if they give you the diameter, you can just write that as pi times the diameter, right? Most of the time we're using 2 pi r. So suppose we have a circle and we have a radius of 6, okay? And they say, what is the entire circumference? Well, you plug in 2 pi times 6, and that would be 12 pi units, whatever the units are listed as. And normally we'll be listing these in terms of pi. But what if they don't want the whole circle? What if they just give, say, an angle of 120 degrees here for the central angle, or the arc measure of 120 degrees? We could give either one because they're going to be the same. Central angle and arc measure are the same. How do you find the arc length of this arc right here? It's just part of a circle. Well, what part is it? It's 120 divided by 360, because there's 360 total degrees in a circle. We're using 120 of them. So it's 120 over 360 times 2 pi r. Again, when we go through and plug in the radius of 6, that's going to be 2 pi times 6. But this big fraction up front, the 120 over 360, the zeros divide out immediately. So that's 12 over 36, and that simplifies to 1/3. Now let's multiply this together. We still have the 2 pi 6, which we said a while ago was 12 pi. So this is going to be 12 pi divided by 3 units. But the 3 and the 12 will simplify to a 4 over 1. So we have 4 pi units for this arc length. It's 1/3 of the entire thing, okay? And that was section 1. Section 2 is dealing with area of a circle. Well, the area of a circle is pi times the radius squared. So if we wanted the area of this circle, we would take its radius, which we said was 6, and just plug it in. We have to square the 6 first, so that's going to be 36, and we would leave this as 36 pi units squared. Get that in there. All right, it's square units because we're talking about area. Well, this region inside here is called a sector. And so the area of the sector, what's the same thing as finding the arc length? How much of the circle are you actually using? You're using 120 degrees out of 360. It's the same fraction that we saw right here, 120 over 360, times, but now since we're dealing with area, it's what part of the circle? Well, the whole circle is pi r squared. Again, this fraction, 120 over 360, simplifies to 1/3 pi times 6 squared. Well, we already know the pi 6 squared. That's 36 pi. So this is 1/3 of 36 pi units squared, and that simplifies to 12 pi units squared. Got to put the pi in. 12 pi units squared. Anytime that you only have a part of a circle, you got to find out what part. What's the ratio, that fractional part? Well, you take the central angle or the arc measure here or here. Either one could be given, and you divide by 360. That's the fractional part of the circle that we're actually using. So once we have that down, then we can go through and multiply by either the circumference, right, an entire length perimeter of the circle, or by the area, the entire area of the circle. That gives us the area of the sector or the arc length, and that's what we start with. Then when we got into section 3, section 3 was areas of regular polygons. So let me go to a blank page here. Let's look at an area of a regular polygon. The formula for the area of a regular polygon is 1/2 apothem times perimeter. Now, the perimeter is always the perimeter of the base. Anytime you see this capital P, it's the perimeter of the base. In fact, all of the capital letters are dealing just with the base. This apothem is, it's actually the height of a triangle inside this regular polygon once you form it. We'll show an example here in a minute. But this is actually the distance from the center perpendicular to a side. And so we'll look at that here in just a second. Let's take a regular polygon, and we'll call this one a pentagon because these occur a lot, right? Something like this. Here is a regular pentagon. All the sides have exactly the same length. All the angles are congruent. Okay. Now, if you want to draw all the radii, a radius goes to the vertex, And for a pentagon, we have 5 of them because there's 5 sides. All of these little triangles that are formed are congruent isosceles triangles. All these green radii have the same length. Again, we call them radii because you could actually draw a circle going through all of the vertices, circumscribe the circle about the regular polygon. So these are all the same. Well, then if you want to find the angles here, all 5 of these have to also be the same. They're congruent. So marking these, but we know the sum of all 5 of those. If you take all those together around that central point, that forms 360. It's one complete circle. So 360 divided by 5 would be 72 for each one of these, 72 degrees. Now, for this one on the bottom, I'm going to drop this perpendicular. That is the apothem, right? If they give you the apothem length, great. You don't have to do any more work. If they don't, what you've got to do is take this 72 and split it down the middle. Why is it split? Because this apothem is not just an angle bisector, it's also a median of that little isosceles triangle. It's a median of the little triangle. These 2 segment lengths here on the end are both the same, all right? It's been cut into. It's a perpendicular bisector. It's every one of those that we had, altitude, median, angle bisector, and perpendicular bisector. That apothem is because it's an isosceles triangle. That's why we studied isosceles triangles so much. Once you know this, they will give you either the radius, the green, or they'll give you a side length, one of the red lengths. And then once you know either one of those, you'll have to use SOHCAHTOA, depending upon what's given, to solve for this length, the apothem length. We can do some examples a little bit later. Let's take a look at a regular polygon that has an apothem given. Something like this. Draw a hexagon this time. Hexagon is a special case. All right. And again, we're going to say all these angles are the same. This is supposed to be regular, so we're going to make it sort of look like it is. All right. So here is a radius. And let's just say that this radius has a length of 8. Right? If you draw all the other radii to the vertices here, you're going to separate this again into a whole bunch of congruent triangles. And before we said that all of these triangles would be isosceles. Well, this is the one case where it's not just isosceles, it's also equilateral. If you take all of the angles here, you got 6 of them. Their sum is 360. When you divide by 6, 360 divided by 6. Each one of these is 60. Well, since these are all isosceles triangles, that means the two base angles on each of these triangles has to be congruent. Well, if this angle is 60, then that means the sum of the other two, when you subtract 60 from 180, has got to be 120. 120 divided by 2, this is now an equilateral triangle, equiangular triangle, and when you drop the apothem, right, that's the height of this triangle, the altitude, there's the apothem length. This is not something that we have to use SOHCAHTOA for. This is a special right triangle. We actually have a 30, 60, 90 triangle right here, okay? Because it's a 30, 60, 90, if we know that this radius is 8, and that's what we said it was, the length of this short leg of the right triangle is 4. Now again, we've bisected this side, so that's 4 and 4 on either side. But how do you get the apothem? You multiply the short leg times the square root of 3, so that's 4 root 3. So the area of this polygon would be 1/2 apothem times perimeter, which is 1/2 of 4 root 3 times the perimeter of this hexagon, 6 sides, all side length of 8, so that would be times 48. Again, if you multiply these together, you can take half of 48 first, which is 24, and then 4 times 24 would give 96 root 3 units squared, right? And that's how you would find the area, the exact area. Now, if it says to round to the nearest tenth, sure. Punch that in on your calculator, 96 root 3. Round to the nearest tenth. If it says in there is thousandth, all right, you can take that as far as you want. But that's finding the areas of regular polygons. You always have to find the apothem, and that's the height of the small triangle that you make inside. It's the distance from the center perpendicular to the side. Now then, the rest of this chapter was not laid out real well as far as surface area. So this is when we went to finding surface areas of prisms and cylinders, then pyramids and cones, and then lastly we got the both surface area and the volume of spheres, one section, and then we picked up the volume of the prisms, cylinders, pyramids, and cones, all of those together. So really this is just some nice shapes. So let's take a look at a prism and a cylinder. They both have the same form. If you want the surface area of each of these, you basically have the same formula. It's the lateral area plus 2 bases. That's the same for both. But now the more specific form for the lateral area, instead of just saying the lateral area, and again you can find that any way that you want, but if you use a formula, there is one, take the perimeter of the base, again capital P, that's for the base, times the height of the prism, plus the area of whatever your bases are. Again, the base can be any shape, so we don't really know, right? But now for the cylinder, we do know a little bit more specific. The perimeter of a circle, because a cylinder has a circular base, is not just, we don't just say perimeter, we say circumference. The circumference is 2 pi r times the height of the prism, plus 2 times, well again, the area of a base. If your base is a circle, and that's what it is for a cylinder, this is going to be pi r squared. That's the most specific that you can get for a cylinder, and the most specific that you can get for a prism, all right? That's the specific form of the surface area. Now, what if we're dealing with volume? All right, that was the last thing that we had, volume. The volume of any prism is just the area of the base times the height of the prism. This one is normally the very easiest one to find. So we're going to start with this. But now again, for a cylinder, you know the area of the base is always going to be a circle. So we take the pi r squared that we had before, write it first for the base, times the height of the prism. And that's how we find the volume of a prism and a cylinder specifically. Now what do these look like? Well, let's take an example. Here is a square base prism. And let's just say it has dimensions of, let's say 8 for the sides here. And again, those could change. It could be rectangular, but we're doing square right now. And I'll say it has a height of 12. All right, just making numbers up. It's going to ask you for the total surface area. It's going to ask for the volume, both of them. Well, for the surface area, the total surface area is the lateral area plus 2 bases, or the more specific, perimeter times height of the prism plus the area of both bases. Now these bases in this problem are both squares. The area of a square is just the side length times itself, or s squared. So let's take a look. What is the perimeter of this base? Well, I'm going to start at this vertex because the base is the top here. I'm going to go 8 plus 8 plus 8 plus 8. That total perimeter there is 32 times the height of the prism is 12. Right? So I'm plugging that in. Plus 2 times, well, what is this side length of the square? Well, that's 8, and that's going to be squared. Well, when you multiply 32 times 12, that's 12 32s. That's going to be 384 for the lateral area. So let me move it over here. 384, that's the lateral area, plus each base is 64. That's the 8 squared. We know that from our multiplication tables. When you multiply 2 times 64, that's 128. When you add these two together, the 384 plus the 128, that's going to be 512. 512, and again, units squared, because we're talking about surface area. Now, how do we find the volume? Let's find the volume. The volume is the area of the base times the height. There's a whole lot less calculation here. We already have all of this information from finding the total surface area. The base right here, that's the side squared. That's the 8 squared. Going to plug that in. The height of the prism is the 12. Plugging that in. This is just 64 times 12. That's 640 plus 128. So 640 plus 128 is 768. 768 units cubed. Again, it's cubic because we're talking about volume. And this is the first part of the video. This takes us down through surface areas of prisms and cylinders. We'll do a cylinder on the next part. Just don't want these to get too long. And then we'll also move to pyramids and cones and pick up the spheres for the last part.